Saturn has always been a marvel of the solar system. With its stunning rings, mysterious atmosphere, and overwhelming size, it's no wonder that it continues to captivate scientists and skywatchers alike. But behind its beauty lies a complexity that challenges some of our most fundamental assumptions about how planetary systems work. The gas giant Saturn, the second largest planet in our solar system after Jupiter, is composed primarily of hydrogen and helium. It has no solid surface, only thick, swirling clouds stretching thousands of kilometers deep into its gaseous interior. Temperatures in its upper atmosphere hover around -113 degrees Celsius, while pressures deep below could crush anything sent there. But what truly makes Saturn stand out are its iconic rings. These rings are not solid, like a CD or vinyl disc. Instead, they're composed of billions of individual pieces of ice, dust, and rock. Some are as small as grains of sand, others as large as buses or small buildings, and they orbit Saturn at incredible speeds, forming thin, precise bands that can stretch for hundreds of thousands of kilometers, yet be only a few meters thick. This razor-thin structure is one of the great mysteries of planetary science. Why does Saturn have such spectacular rings, while Jupiter, Uranus, and Neptune, though they also have ring systems, have ones that are faint and barely visible? What keeps Saturn's rings from collapsing into the planet or dispersing into space? And more intriguingly, how old are these rings? For decades, scientists believed the rings were as old as the planet itself, over 4 billion years. But recent data from the Cassini spacecraft has shaken that assumption. Before it plunged into Saturn's atmosphere in 2017, Cassini spent years orbiting the planet, collecting high-resolution data about the rings. What it found shocked researchers. The rings may only be 100 to 200 million years old. If that's true, then they appeared well after the age of the dinosaurs. That raises an even deeper question. How did they form? One theory suggests that a large icy moon of Saturn was torn apart by tidal forces. As it drifted too close, Saturn's gravity shredded it into countless fragments, which then spread into a disk. Another idea is that cometary collisions may have bombarded Saturn's moons, scattering icy debris into orbit. Either way, the rings may be a temporary feature, destined to fade over the next few 100 million years as the material gradually rains down onto the planet. And yet, despite their impermanence, the rings influence Saturn in strange and unexpected ways. They interact gravitationally with Saturn's moons, shaping their orbits and even their geological activity. Enceladus, one of Saturn's icy moons, sprays plumes of water vapor and organic molecules from its south pole, possibly indicating a subsurface ocean. Some scientists believe that the rings help maintain this activity by influencing Enceladus's orbit, causing tidal heating in its interior. Even more fascinating is that the rings may affect Saturn's atmosphere itself. Observations have shown that the ring shadows can cool portions of the planet's upper atmosphere, creating seasonal weather patterns. In other words, the rings are not just ornaments, they are active participants in the system's complex dance. But Saturn isn't only about its rings. The planet's magnetic field is another puzzle. It's perfectly symmetrical, unlike Earth's or Jupiter's, which challenges our understanding of how magnetic fields are generated. The planet also has hexagonal storm patterns at its north pole, rotating with eerie precision year after year. And then there's Titan, Saturn's largest moon, bigger than the planet Mercury. Titan has a thick atmosphere, rivers and lakes of liquid methane, and possibly a subsurface ocean. It's one of the most Earth-like worlds we've ever encountered, despite being frigid and alien. Saturn, in all its grandeur, reminds us that beauty and mystery go hand in the cosmos. It's a world of paradoxes, majestic but deadly, simple in appearance but complex in nature. With every probe we send, and every image we capture, we uncover another layer of awe and another reason to keep exploring. At Infinity Beyond, we dive into these cosmic wonders not just to observe, but to understand. Saturn is not just a planet, it's a window into the forces that shaped our solar system and may govern worlds beyond.